here.
Okay, so let's start right here. We're given 2 points. You see them? There's one, there's another. Plot them on your graph. Oh, that's not. Once you have your 2 points plotted, use your handy dandy ruler to draw a really pretty line. You're looking for it to be straight because you want to see if you're going to have a pretty y-intercept. So be careful. Is the point.
Will it be a certain color? The line?
Whatever color you want. The other lines we're going to draw need to be a different color, so that's up to
Wait,
you.
we have to do the line and the color? Yeah.
Okay, this one's good.
Your notes, you do whatever you want. I could take these 2 points and put them in a table, couldn't I?
Yes.
No, I couldn't.
Oh, no. Yes, yes, yeah.
I could. I think so. When you look at this line, is it positive or negative?
It is a negative.
So therefore, if I were going to write the equation, I should immediately put a negative for my slope value, right? So I don't mess that up,
Yes.
correct? Okay, so you have a choice. You can either use bird beaks with this table, or you can count your rise over run to find your slope. So
Bird beats.
whichever one floats your boat. Once you get your slope, compare it with your partners and see if y'all have the same slope.
I have no partner.
I'm really bad at this one.
So then there'd be negative over that.
I'd ask you one question before you tell me this slope. Does this look flat or steep? Steep. The flatter a line gets, the closer your slope gets to 0. The steeper the line gets, the bigger your slope is. So if you tell me this slope is 1/2, and you just told me it was steep, those two things don't go together, do they? That means you put x over y instead of y over x. How do I get from 1 to -9? Not exactly. -10. How do I get from -2 to 3?
+5.
Which would give me -10 over 5, which gives me
-2.
There you go. I already got my negative, so there's my -2x. What's my y-intercept? Did we end up with a pretty one?
No.
No? Well, let's see. It's supposed to go down 2 over 1, down 2 over 1. I got a pretty one. Did you not use your pretty ruler?
I used it.
I got a -3. I agree. There you go. So there's f of x. That would be our first one. You ready to do the next one? Get a new color. I'm going to let this one be blue. You don't have to, but I'm working on blue right now. I gave you some space at the bottom of your paper. We're going to write g of x apparently is supposed to equal f of x minus 1. What is f of x?
-2x minus 1.
Thank you. -2x minus 3. But instead of putting an x, I'm going to put a parenthesis. How come? Because I got to put that stuff in for x, don't I? This doesn't say f of x. This is saying take this stuff right here and put it in for x, right? So I just put parentheses there. So what am I going to put inside of my parentheses? Well, what's inside of these parentheses?
X minus 1.
So I'm going to put the same thing in those parentheses.
Don't put parentheses around the -3 because it's like where
The -3 is on the outside. I only put the parentheses where the x was. So I wrote it -2 parentheses minus 3. The parentheses is where the x was. Could we simplify that? How would we do that?
Distribute
Okay. What do I get?
negative 2x.
I agree. Now what do I get?
Negative
Positive 2.
Positive 2. I agree. I wouldn't distribute to that negative 3, would I? No, because it's not in the parentheses. Can we simplify that? Okay. What could I do?
Yep. Minus
These will combine, right?
Yes.
To be what?
Negative 1.
So that means I got negative 2x minus 1.
Yes.
So apparently g of x is negative 2x minus 1. Can we graph that? Is this in slope-intercept form or is it in HK form? Slope-intercept. So that means they must have given you the slope and an intercept. What intercept did they give you?
Negative 1.
And they gave you the y, which equals negative 1. So where are you going to plot that negative 1?
On the y.
On the y. So I'm going to go put me a negative 1 right there. From that point, what am I going to do with the slope?
Go down 2 over 1.
I'm going to go down 2 over 1. Down 2 over 1. Down 2 over 1. Could I also go up 2, back 1?
Yes.
As long as one of the values goes in a negative direction. Use your handy dandy little ruler and draw yourself a blue line.
With a different color.
Well, I'm doing it with the same color I was doing all my work in. So I can easily see they go together.
Wow.
Handy dandy rule.
What type of lines do those look like?
Negative.
Negative.
Okay, I agree. What?
Parallel.
Do you think they look like they're parallel? Are you sure they're parallel?
Yeah.
They look like they're parallel, but are you sure that if you went just way, way, way out there, they wouldn't cross somewhere?
No.
You are sure they wouldn't cross somewhere?
No, they wouldn't. No, we're not sure.
How are you sure that they wouldn't cross somewhere? Then you're not sure. If you don't know, you're not sure. Anybody have some added information that could definitely tell us, nope, they're never crossing?
Uh,
No.
And it's okay if you don't, because I haven't taught you that yet. But
miss.
somebody in second period knew, so.
I heard.
What do you think?
It's got they both have the same slope.
Okay.
How do you?
If they have the same slope, then they're going down and over at the same rate, aren't they? Then they're never going to cross. So sometimes they'll look parallel and they're not because maybe their slopes are slightly different. But in this case, they actually have the same slope, so yes, they're parallel. Of course, that means they can't be on top of each other also. Okay, so let's look at a few things. Let's compare this purple one to this blue one. When I look at this purple one, is this blue one steeper or flatter than the purple one?
No. Steeper.
They're the same, right? Because the slope is the same. It's not steeper or flatter. They're just the same. Did this blue one, in comparison to the purple, translate up or down? How much? Be specific.
Up to.
Up 2, right? The y-intercept was here, now it's there. So, up 2. Now I want you to look at the x-intercept of the purple one and decide if the blue one increased or decreased from it.
The blue one.
How do you know? Because it went to the right, and when you move to the right, your x values get bigger, don't they?
Yes.
For example, this right here is like negative 1.5 or something. Well, this one's almost to 0. It's maybe negative 1/2. Isn't negative 1/2 bigger?
Yes.
Yeah, so as it moves to the right, so the x-intercept increased. New color. Let's do our h of x. Right up there at the top where I put the box. I'm going to give me a blank page because y'all got a little more space than I do, and if I hit the extend button, it's going to get really small. H of x apparently is f of x plus 2. Whoop, no, it's totally not that. I don't know, I'm just coming up with my own stuff here. Let's try that again. F of x plus 2. What does f of x equal? Negative 2x minus 3. So if f of x equals negative 2x minus 3, couldn't I replace it with what it equals? So I'm going to put a parenthesis here because I'm not going to use f of x anymore. What am I going to replace f of x with? What it equals, which is negative 2x minus 3. Could we simplify that? How would we do that? Do I need those parentheses? Is anything on the outside multiplying to it? So now what?
Negative 3.
And I get
Negative 1.
oh, okay. Is that in HK form or is that in slope-intercept form? So if it's in slope-intercept form, that means they must have given you the slope and an intercept. So what's the intercept, bless you?
Negative 1.
Negative 1, so I'm going to go over here and I'm going to put negative 1. From that point, I'm going to do the slope. So what do I do?
Negative 2 over 1.
So down 2 over 1? Down 2 over 1? Wow, what's happening?
It's the same.
They're the exact same.
That's not good.
It's okay.
No, boy.
It certainly doesn't, they certainly wouldn't be parallel though, would they?
No.
How many solutions does this scenario have between this blue and red?
Every single.
Every single one. How do we say that in the math world?
Infinite.
Infinitely many solutions, right? Because they're the same. Everywhere they go, they're in the same place. Would you consider this red line to be steeper or flatter than the blue?
The same.
The same. Would you consider this red line to be shifted up or down in comparison to the blue?
Same.
Because everything's going to be the same, right? Okay, so let's see. This is what I'd like for you to notice. Originally, you remember how this blue one right here had this f of x minus 1? Okay. Is that minus 1 an inside or outsider?
Inside.
It's on the inside, right? So does it impact the x's or the y's?
The
What's on the inside? An x. So
An
it
X.
impacts the x's. And insiders are also
liar.
liars. So is it saying to shift it to the right or to the left?
To the right.
By how much?
1.
1. So this purple graph compared to the blue, did it shift it to the right one?
Yes.
It did. We did all that math and we ended up just shifting it to the right one. Did we have to do all that math? No, we could have just scooted that sucker over, right? Okay, so now let's look at this red one. This red one doesn't shift it left or right, does it?
No.
What does the red one do?
Go up.
It shifts it up too. But yet we managed to land in the exact same place. So if I asked you how it shifted, what would you say? If all you did was see the graph and none of that stuff up there, could you tell me it went right one?
Yes. Yes.
Yeah. Could you tell me it went up two?
Yes.
Yeah, because it doesn't matter. Both of those are true. Could you tell me it went right one and up two?
No.
Yes.
Let's see what right one and up two looks like. Right one, up two. So could you tell me that?
No.
No, you really just got to tell me one or the other. But that's what's going to happen in these linear graphs. There's probably more than one way you can describe the movement. Okay? Let's try another. I want to go to the inside. A line f of x that contains these points. Plot your lines, draw your line. Plot your points, draw your line. Can you write the equation for your line? You will need to find the slope and the y-intercept to do so. If your y-intercept is not pretty, then you would use the HK form, but in this case it's pretty. If it's not pretty, you might want to, I don't know, check out your ruler and see if it's bent. Candace, what'd you get for the slope?
I haven't got it yet.
Okay. Blaze, what'd you get for the y-intercept? Negative,
Wait, no,
What?
-2.
negative 2? Okay, I'm gonna go ahead and write my negative 2 up here. And all I need left is my slope. Wait.
There. Here.
So to find the slope, you could count, rise, or run. You could put it in a table and do bird beaks. Or you could do y minus y over x minus x, right?
Right.
Should we practice one of the y minus y over x minus x's? No, we shouldn't? Okay, good to know. I got Candace over there and tell me. Any moment. Does that reduce to something?
3, 2, negative 2.
I agree. That was what I was getting ready to ask. You always need to take a look. If you write a positive slope down, you might want to take a look at your line and make sure your line is positive as well. Always look at your line and make sure they match. Okay, so now let's try this. We need a new color. We've got to do this new graph g of x, which is apparently going to equal f of 2x. Well, what is f of x? Negative 2x minus 2. So if there's something else in my parentheses, I'm obviously going to have to replace it, correct? So I'm going to do negative 2 parentheses minus 2. So instead of putting x, I'm going to put parentheses. What's in my parentheses? So what am I going to put in my new parentheses? 2x. So would this simplify? What would it become?
Negative.
So negative 4x minus 2?
Yes.
Is that slope-intercept form or HK form? So if it's slope-intercept, they must have given you the slope and the y-intercept. Can you graph the y-intercept? Okay, go for it. From your y-intercept, what will you do with the slope?
Go down.
Go down 4 and go over 1. I agree. You could also go up 4 and back 1, correct? Once you've done that, get your handy dandy ruler and draw your line. If we were to compare our blue line to our purple line, would you consider our blue line to be steeper or flatter than the purple?
Steeper.
Steeper, I agree. Oh, whoops, new pen, new pen. Anybody have a problem with being able to tell if it's steeper or flatter? So if you think about it this way, these are both negative. So say I was walking over here and you thought of them as a hill. If I were walking up the blue hill, do you agree more than likely I would fall down and I would roll down to the bottom? But the purple is a little bit easier of an incline for me to walk, right? So the steeper that gets, or the closer it gets to being vertical, okay? The blue line compared to the purple, did it translate up or down?
It didn't translate.
Didn't move up or down, did it? Aren't they sharing the same y-intercept? So it's neither. Just because I asked the question doesn't mean it happened. It didn't shift up or down, did it? The y-intercept stayed the same. Now take a look at your x-intercepts, comparing your purple to the blue. Did the blue one increase or decrease in comparison? It increased. These are all the kind of ways you would describe these transformations. Right now I'm providing them for you. Let's try one more. Over here we got to plot 2 points. Can you do that? Okay. Once you got your 2 points, get your ruler. Oh, it smells very good. Find your slope. I'm going to find the slope by doing the formula, just in case you need a little practice with the formula. So I'm going to work right up here. 1 minus a negative 7 over 1 minus a negative 1. Would I write down a slope of 8 over 2? No way. I would simplify it. And what would I get? 4. So I got a slope of 4. Then I put my x. My x always goes next to my slope, correct?
Yes.
Then what's my y-intercept? Is it pretty?
No.
Let's see. Down 1, 2, 3, 4 over 1. Isn't it right there? At negative 3? My line's a little off, so it doesn't look pretty. That's why it kind of helps to have the slope, because then you can determine if it is pretty. We got a new line? So let's see. It says a line with a slope that is halved.
So it would be 2.
How'd you get that?
Half of 4 is 2.
Half of 4 is 2. So if they tell me to half the slope, I'm just going to half the slope. Well, if the slope is 4, half of that would be 2. Should I also half the y-intercept?
Yes.
Why? Did it tell me to? No, it just said half the slope. It didn't say change the y-intercept at all, so what's going to happen with the y-intercept?
It'll stay
It's going to stay exactly the same. Can we graph that?
Yeah.
They gave you what? Slope-intercept, so you got the slope and the y-intercept. How many points do you need to be able to draw your line?
At least
You need 2, right?
2.
How come you think I'm doing more than that?
Because they're so close together.
Yeah, it allows me to graph it on here a little better. Plus, if you're, trying to do certain things and you want it to be really accurate, then of course more points are going to help you. What type of lines are f of x and g of x?
Positive.
I agree. Are they parallel?
No.
No.
So if they're not parallel, how would you describe them to me?
Intersect.
There you go, they're just intersecting. Nothing fancy about it. I bet that box isn't big enough for that word. Certainly not on mine. Looking at blue compared to purple, is the blue one steeper or flatter?
Flatter.
It does. I could walk up this blue one a whole lot easier than I could walk up that purple one. Did the blue one shift up or down? It stayed the same. It didn't go up or down, so I'm just going to put neither. Looking at the blue one and comparing it to the purple, did the blue one's x-intercept increase or decrease? Questions about that? You're all good?
Oh.
You have a classwork assignment using these skills.